Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Machine Learning Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are creating a deep neural network classification model using a dataset with categorical input values. Certain columns have a cardinality greater than 10,000 unique values. How should you encode these categorical values as input into the model? The options are: Option A, convert each categorical value into an integer value. Option B, convert the categorical string data to one-hot hash buckets. Option C, map the categorical variables into a vector of Boolean values. Option D, convert each categorical value into a run-length encoded string.
To arrive at the correct answer, we focus on the keywords: deep neural network classification model, categorical input values, cardinality greater than 10,000, encode these categorical values.
The correct answer is option B, convert the categorical string data to one-hot hash buckets.
Why is this correct? B. Hashing with one-hot encoding effectively handles high cardinality categorical data by restricting the vocabulary to a predefined number of hash buckets. This prevents excessively large, sparse input vectors and out-of-memory issues in deep neural networks. Why are the others incorrect? A. Simple integer encoding introduces a false ordinal relationship between categorical values, which can mislead the neural network during training, as it implies magnitude and order that do not naturally exist. C. Standard Boolean mapping, one-hot encoding, for cardinality over 10,000 creates excessively sparse, high-dimensional input vectors, leading to significant memory consumption, increased computational overhead, and potential overfitting. Why are the others incorrect? D. Run-length encoding is a data compression technique for repeating consecutive values. It is completely unsuitable for transforming categorical data into numerical features required by deep neural network models.
You are the director of data science at a large company, and your data science team has recently begun using the Kubeflow Pipelines SDK to orchestrate their training pipelines. Your team is struggling to integrate their custom Python code into the Kubeflow Pipelines SDK. How should you instruct them to proceed in order to quickly integrate their code with the Kubeflow Pipelines SDK? The options are: Option A, use the func_to_container_op function to create custom components from the Python code. Option B, use the predefined components available in the Kubeflow Pipelines SDK to access Dataproc and run the custom code there. Option C, package the custom Python code into Docker containers and use the load_component_from_file function to import the containers into the pipeline. Option D, deploy the custom Python code to Cloud Functions and use Kubeflow Pipelines to trigger the Cloud function.
To arrive at the correct answer, we focus on the keywords: Kubeflow Pipelines SDK, integrate their custom Python code, quickly integrate.
The correct answer is option A, use the func_to_container_op function to create custom components from the Python code.
Why is this correct? A. The func_to_container_op function in the Kubeflow Pipelines SDK provides the fastest way to turn a standalone Python function into a reusable pipeline component, bypassing manual Docker image creation for quick integration. Why are the others incorrect? B. Using Dataproc introduces unnecessary complexity and infrastructure overhead for simply running Python code. It does not provide a quick integration path compared to using native SDK component creation functions. C. Packaging code into Docker containers manually is a valid but slower and more complex process. It contradicts the requirement to quickly integrate the code compared to using lightweight Python component functions. D. Deploying code to Cloud Functions adds external dependencies and infrastructure management overhead. It is not the most direct or quickest way to integrate custom Python code within a Kubeflow pipeline.
You work for a company that provides an anti-spam service that flags and hides spam posts on social media platforms. Your company currently uses a list of 200,000 keywords to identify suspected spam posts. If a post contains more than a few of these keywords, the post is identified as spam. You want to start using machine learning to flag spam posts for human review. What is the main advantage of implementing machine learning for this business case? The options are: Option A, posts can be compared to the keyword list much more quickly. Option B, new problematic phrases can be identified in spam posts. Option C, a much longer keyword list can be used to flag spam posts. Option D, spam posts can be flagged using far fewer keywords.
To arrive at the correct answer, we focus on the keywords, uses a list of 200,000 keywords, start using machine learning, main advantage.
The correct answer is option B, new problematic phrases can be identified in spam posts.
Why is this correct? B. Machine learning models can generalize from training data to recognize semantic patterns and new variations of spam phrases, overcoming the limitations of a static keyword list. Why are the others incorrect? A. Simple keyword matching algorithms are generally computationally faster and less resource-intensive than running inference on a machine learning model. C. The primary benefit of machine learning is not to increase the size of a keyword list, but to generalize and understand context beyond static text matching. D. While an ML approach might not rely on explicit keywords, its main advantage is the ability to adapt to and identify new spam patterns, not just reducing keyword quantity.
You are an ML engineer at an e-commerce company and have been tasked with building a model that predicts how much inventory the logistics team should order each month. Which approach should you take? The options are: Option A, use a clustering algorithm to group popular items together. Give the list to the logistics team so they can increase inventory of the popular items. Option B, use a regression model to predict how much additional inventory should be purchased each month. Give the results to the logistics team at the beginning of the month so they can increase inventory by the amount predicted by the model. Option C, use a time series forecasting model to predict each item's monthly sales. Give the results to the logistics team so they can base inventory on the amount predicted by the model. Option D, use a classification model to classify inventory levels as under_stocked, over_stocked, and correctly _stock. Give the report to the logistics team each month so they can fine-tune inventory levels.
To arrive at the correct answer, we focus on the keywords, predicts how much inventory, each month.
The correct answer is option C, use a time series forecasting model to predict each item's monthly sales. Give the results to the logistics team so they can base inventory on the amount predicted by the model.
Why is this correct? C. Time series forecasting is the ideal approach for predicting future continuous values based on historical, time-indexed data, effectively handling seasonality and trends required for monthly inventory planning. Why are the others incorrect? A. Clustering groups similar items based on features but does not predict future numerical values or account for temporal changes needed for inventory forecasting. B. While regression predicts continuous values, standard regression models do not inherently model temporal dependencies, seasonality, and trends as effectively as specialized time series models. D. Classification is used to predict discrete categorical labels, like stock status, rather than the continuous numerical values required to determine exact inventory quantities.
You are an ML engineer at a bank. You have developed a binary classification model using AutoML tables to predict whether a customer will make loan payments on time. The output is used to approve or reject loan requests. One customer's loan request has been rejected by your model, and the bank's risks department is asking you to provide the reasons that contributed to the model's decision. What should you do? The options are: Option A, use local feature importance from the predictions. Option B. Use the correlation with target values in the data summary page. Option C. Use the feature importance percentages in the model evaluation page. Option D. Vary features independently to identify the threshold per feature that changes the classification.
To arrive at the correct answer, we focus on the keywords, AutoML tables, customers, reasons that contributed to the model's decision.
The correct answer is option A. Use local feature importance from the predictions.
Why is this correct? A. Local feature importance provides the exact contribution of each feature for a single, specific prediction, which perfectly addresses the need to explain why one individual customer's loan was rejected. Why are the others incorrect? B. Correlation in the data summary page only describes general relationships across the entire dataset, not the specific reasons for an individual prediction. C. Feature importance in the model evaluation page is global, meaning it shows which features are important for the model overall, not for a specific customer's prediction. D. Varying features manually is computationally inefficient and unnecessary, as AutoML tables natively provides local feature importance to explain individual predictions.
You lead a data science team at a large international corporation. Most of the models your team trains are large-scale models using high-level TensorFlow APIs on AI platform with GPUs. Your team usually takes a few weeks or months to iterate on a new version of a model. You were recently asked to review your team's spending. How should you reduce your Google Cloud compute costs without impacting the model's performance? The options are: Option A. Use AI platform to run distributed training jobs with checkpoints. Option B. Use AI platform to run distributed training jobs without checkpoints. Option C. Migrate to training with Kubeflow on Google Kubernetes Engine, and use preemptible VMs with checkpoints. Option D. Migrate to training with Kubeflow on Google Kubernetes Engine, and use preemptible VMs without checkpoints.
To arrive at the correct answer, we focus on the keywords, few weeks or months, reduce your Google Cloud compute costs without impacting the model's performance.
The correct answer is option C. Migrate to training with Kubeflow on Google Kubernetes Engine, and use preemptible VMs with checkpoints.
Why is this correct? C. Preemptible VMs on GKE significantly reduce compute costs. Because they can be terminated at any time, using checkpoints is essential for long-running jobs to ensure training progress is saved and can be resumed without impacting performance. Why are the others incorrect? A. This approach uses standard on-demand pricing, failing to achieve the significant cost reductions provided by preemptible VMs. B. This does not reduce costs because it doesn't use preemptible VMs. Furthermore, omitting checkpoints risks losing weeks of progress upon any failure. D. While preemptible VMs lower costs, running long jobs without checkpoints means all progress is lost when a VM is preempted, preventing successful completion.
You are training a deep learning model for semantic image segmentation with reduced training time. While using a deep learning VM image, you receive the following error: the resource project/deep learning platform/zone/Europe West 4C/accelerator types/NVIDIA Tesla K80 was not found. What should you do? The options are: Option A. Ensure that you have GPU quota in the selected region. Option B. Ensure that the required GPU is available in the selected region. Option C. Ensure that you have preemptible GPU quota in the selected region. Option D. Ensure that the selected GPU has enough GPU memory for the workload.
To arrive at the correct answer, we focus on the keywords, the resource project/deep learning platform/zone/Europe West 4C/accelerator types/NVIDIA Tesla K80 was not found.
The correct answer is option B. Ensure that the required GPU is available in the selected region.
Why is this correct? B. The was not found error indicates the specific accelerator type, NVIDIA Tesla K80, is not physically available in the selected zone, Europe West 4C. You must ensure the required GPU model is offered in that region/zone. Why are the others incorrect? A. A quota error would explicitly state quota exceeded rather than was not found. This issue is about hardware availability in the zone, not account limits. C. Preemptible quota is irrelevant because the error states the resource type itself cannot be found in the specified zone, indicating unavailability, not a quota issue. D. This error occurs during resource provisioning because it cannot find the specified GPU type. It is unrelated to out-of-memory errors that happen during workload execution.
You work on a growing team of more than 50 data scientists who all use AI platform. You are designing a strategy to organize your jobs, models, and versions in a clean and scalable way. Which strategy should you choose? The options are: Option A, set up restrictive IAM permissions on the AI platform notebooks so that only a single user or group can access a given instance. Option B, separate each data scientist's work into a different project to ensure that the jobs, models, and versions created by each data scientist are accessible only to that user. Option C, use labels to organize resources into descriptive categories. Apply a label to each created resource so that users can filter the results by label when viewing or monitoring the resources. Option D, set up a BigQuery sync for cloud logging logs that is appropriately filtered to capture information about AI platform resource usage. In BigQuery, create a SQL view that maps users to the resources they are using.
To arrive at the correct answer, we focus on the keywords: team of more than 50 data scientists, organize your jobs, models, and versions, clean and scalable way.
The correct answer is option C, use labels to organize resources into descriptive categories. Apply a label to each created resource so that users can filter the results by label when viewing or monitoring the resources.
Why is this correct? C. Labels are the standard Google Cloud mechanism for organizing, categorizing, and filtering resources like jobs, models, and versions at scale without creating excessive administrative overhead. Why are the others incorrect? A. Restricting IAM permissions on notebooks limits access to development instances but does not organize deployed jobs, models, and versions. B. Creating a separate project for each data scientist introduces significant administrative overhead and creates silos that hinder collaboration. D. Exporting logs to BigQuery provides monitoring and usage tracking capabilities but does not inherently organize the underlying AI platform resources.
You are training an ML model using data stored in BigQuery that contains several values that are considered personally identifiable information, PII. You need to reduce the sensitivity of the dataset before training your model. Every column is critical to your model. How should you proceed? The options are: Option A, using Dataflow, ingest the columns with sensitive data from BigQuery, and then randomize the values in each sensitive column. Option B, use the Cloud Data Loss Prevention (DLP) API to scan for sensitive data, and use Dataflow with the DLP API to encrypt sensitive values with format-preserving encryption. Option C, use the Cloud Data Loss Prevention (DLP) API to scan for sensitive data, and use Dataflow to replace all sensitive data by using the encryption algorithm AES-256 with Assault. Option D, before training, use BigQuery to select only the columns that do not contain sensitive data. Create an authorized view of the data so that sensitive values cannot be accessed by unauthorized individuals.
To arrive at the correct answer, we focus on the keywords: personally identifiable information, PII, reduce the sensitivity of the dataset, every column is critical.
The correct answer is option B, use the Cloud Data Loss Prevention (DLP) API to scan for sensitive data, and use Dataflow with the DLP API to encrypt sensitive values with format-preserving encryption.
Why is this correct? B. Cloud DLP format-preserving encryption allows you to de-identify PII while preserving the format and length of the original data. This maintains the utility of the data for ML model training, fulfilling the requirement that every column is critical. Why are the others incorrect? A. Randomizing values destroys the statistical properties and patterns of the data, which would negatively impact the ML model's ability to learn from those features, making them useless for training. C. Standard encryption like AES-256 with assault destroys the original data format and length, which can disrupt downstream ML training pipelines that expect specific data types, unlike format-preserving encryption. D. Excluding columns with sensitive data directly violates the explicitly stated requirement that every column is critical to your model.
You work at a large organization that recently decided to move their ML and data workloads to Google Cloud. The data engineering team has exported the structured data to a cloud storage bucket in Avro format. You need to propose a workflow that performs analytics, creates features, and hosts the features that your ML models use for online prediction. How should you configure the pipeline? The options are: Option A, ingest the Avro files into Cloud Spanner to perform analytics. Use a Dataflow pipeline to create the features, and store them in Vertex AI feature store for online prediction. Option B, ingest the Avro files into BigQuery to perform analytics. Use a Dataflow pipeline to create the features, and store them in Vertex AI feature store for online prediction. Option C, ingest the Avro files into Cloud Spanner to perform analytics. Use a Dataflow pipeline to create the features, and store them in BigQuery for online prediction. Option D, ingest the Avro files into BigQuery to perform analytics. Use BigQuery SQL to create features and store them in a separate BigQuery table for online prediction.
To arrive at the correct answer, we focus on the keywords: cloud storage bucket in Avro format, performs analytics, creates features, online prediction.
The correct answer is option B, ingest the Avro files into BigQuery to perform analytics. Use a Dataflow pipeline to create the features, and store them in Vertex AI feature store for online prediction.
Why is this correct? B. BigQuery is the recommended Google Cloud data warehouse for analytics. Dataflow processes the data to create features, and Vertex AI feature store provides the necessary low-latency serving for online prediction. Why are the others incorrect? A. Cloud Spanner is a relational database designed for OLTP workloads, not for performing large-scale analytics, which is BigQuery's primary use case. C. Cloud Spanner is inappropriate for analytics, and BigQuery is not designed for the low-latency key-value lookups required for online prediction feature serving. D. BigQuery is an analytics data warehouse and does not provide the low-latency reads required for hosting features for online prediction.
You work for a multinational organization that has recently begun operations in Spain. Teams within your organization will need to work with various Spanish documents, such as business, legal, and financial documents. You want to use machine learning to help your organization get accurate translations quickly and with the least effort. Your organization does not require domain-specific terms or jargon. What should you do? The options are: Option A, create a Vertex AI Workbench notebook instance. In the notebook, extract sentences from the documents, and train a custom AutoML text model. Option B, use Google Translate to translate 1,000 phrases from Spanish to English. Using these translated pairs, train a custom AutoML translation model. Option C, use the document translation feature of the Cloud Translation API to translate the documents. Option D, create a Vertex AI Workbench notebook instance. In the notebook, convert the Spanish documents into plain text, and create a custom TensorFlow Seek translation model.
To arrive at the correct answer, we focus on the keywords: Spanish documents, translations quickly and with the least effort, does not require domain-specific terms or jargon.
The correct answer is option C, use the document translation feature of the Cloud Translation API to translate the documents.
Why is this correct? C. The document translation feature of the Cloud Translation API provides accurate translations directly from documents quickly and with the least effort. It is ideal since domain-specific terms or jargon are not required. Why are the others incorrect? A. Training a custom AutoML text model requires significant effort, which contradicts the requirement for the least effort, and is unnecessary since custom jargon is not needed. B. AutoML translation is intended for domain-specific models. Since custom jargon is not required, using it in generating training data via Google Translate introduces unnecessary effort. D. Creating a custom TensorFlow Seek-to-Seek model requires the most effort for building, training, and hosting, directly contradicting the requirement to get translations quickly and with the least effort.
You are using Keras and TensorFlow to develop a fraud detection model. Records of customer transactions are stored in a large table in BigQuery. You need to pre-process these records in a cost-effective and efficient way before you use them to train the model. The trained model will be used to perform batch inference in BigQuery. How should you implement the pre-processing workflow? The options are: Option A, implement a pre-processing pipeline by using Apache Spark, and run the pipeline on Dataproc. Save the pre-processed data as CSV files in a cloud storage bucket. Option B, load the data into a Pandas data frame. Implement the pre-processing steps using Pandas transformations, and train the model directly on the data frame. Option C, perform pre-processing in BigQuery by using SQL. Use the BigQuery client in TensorFlow to read the data directly from BigQuery. Option D, implement a pre-processing pipeline by using Apache Beam, and run the pipeline on Dataflow. Save the pre-processed data as CSV files in a cloud storage bucket.
To arrive at the correct answer, we focus on the keywords, stored in a large table in BigQuery, cost-effective and efficient way, batch inference in BigQuery.
The correct answer is option C, perform pre-processing in BigQuery by using SQL. Use the BigQuery client in TensorFlow to read the data directly from BigQuery.
Why is this correct? C. Pre-processing directly in BigQuery using SQL is highly cost-effective and efficient since the data already resides there. BigQuery's massive parallelism handles large tables well, and TensorFlow can read directly from BigQuery without needing to export data. Why are the others incorrect? A. Moving data out of BigQuery to cloud storage and using Dataproc adds unnecessary data movement, infrastructure complexity, and cost when BigQuery can process it directly. B. Loading a large table into a Pandas data frame is not scalable and will likely lead to out-of-memory errors. It is not an efficient approach for large datasets. D. Exporting data to cloud storage and running an Apache Beam pipeline on Dataflow introduces unnecessary overhead, data movement, and cost compared to in-place BigQuery processing.
While performing exploratory data analysis on a dataset, you find that an important categorical feature has 5% null values. You want to minimize the bias that could result from the missing values. How should you handle the missing values? The options are: Option A, remove the rows with missing values, and upsample your dataset by 5%. Option B, replace the missing values with the feature's mean. Option C, replace the missing values with a placeholder category indicating a missing value. Option D, move the rows with missing values to your validation dataset.
To arrive at the correct answer, we focus on the keywords, categorical feature, null values, minimize the bias.
The correct answer is option C, replace the missing values with a placeholder category indicating a missing value.
Why is this correct? C. For categorical features, creating a placeholder category for missing values prevents data loss and allows the model to capture any predictive signal associated with the missingness itself, effectively minimizing bias without making assumptions. Why are the others incorrect? A. Removing rows with missing values can introduce bias if the missingness is not completely at random, and upsampling does not recreate the lost information. B. A categorical feature represents discrete categories, not numerical values. Therefore, calculating a mean is mathematically impossible and inappropriate for this type of feature. D. Moving these rows to the validation dataset alters its distribution and fails to address how the model should handle missing values in production, leading to a biased model.
You need to build classification workflows over several structured datasets currently stored in BigQuery. Because you will be performing the classification several times, you want to complete the following steps without writing code: exploratory data analysis, feature selection, model building, training, and hyperparameter tuning and serving. What should you do? The options are: Option A, train a TensorFlow model on Vertex AI. Option B, train a classification Vertex AutoML model. Option C, run a logistic regression job on BigQuery ML. Option D, use scikit-learn in notebooks with Pandas library.
To arrive at the correct answer, we focus on the keywords: classification workflows, structured datasets, without writing code, exploratory data analysis, feature selection, model building, training, and hyperparameter tuning and serving.
The correct answer is option B, train a classification Vertex AutoML model.
Why is this correct? B. Vertex AutoML allows you to perform the end-to-end machine learning lifecycle, including EDA, feature selection, model building, hyperparameter tuning, and serving on structured datasets entirely without writing code. Why are the others incorrect? A. Training a custom TensorFlow model on Vertex AI requires writing code, which contradicts the strict requirement to complete all steps without writing code. C. BigQuery ML requires writing SQL code to train models and perform other tasks, which violates the requirement to complete the workflow without writing code. D. Using scikit-learn and Pandas in notebooks inherently involves writing Python code, contradicting the requirement to perform the steps without writing code.
You are developing an image recognition model using PyTorch based on ResNet 50 architecture. Your code is working fine on your local laptop on a small subsample. Your full dataset has 200K labeled images. You want to quickly scale your training workload while minimizing cost. You plan to use 4 V100 GPUs. What should you do? The options are: Option A, create a Google Kubernetes engine cluster with a node pool that has 4 V100 GPUs. Prepare and submit a TF job operator to this node pool. Option B, create a Vertex AI Workbench user-managed notebooks instance with 4 V100 GPUs and use it to train your model. Option C, package your code with setup tools and use a pre-built container. Train your model with Vertex AI using a custom tier that contains the required GPUs. Option D, configure a compute engine VM with all the dependencies that launches the training. Train your model with Vertex AI using a custom tier that contains the required GPUs.
To arrive at the correct answer, we focus on the keywords: PyTorch, quickly scale your training workload, minimizing cost, 4 V100 GPUs.
Correct answer is option C, package your code with setup tools, and use a pre-built container. Train your model with Vertex AI using a custom tier that contains the required GPUs.
Why is this correct? C. Using Vertex AI custom training with a pre-built PyTorch container minimizes operational overhead and cost, as you only pay for the exact compute resources used during the batch training job. Why are the others incorrect? A. TF job is specifically designed for TensorFlow, not PyTorch. Additionally, manually provisioning and managing a GKE cluster introduces unnecessary operational overhead and cost. B. User-managed notebooks are intended for interactive development. Running a notebook instance continuously with 4 GPUs is not a cost-effective approach for batch training. D. Manually configuring a compute engine VM with dependencies creates unnecessary management overhead compared to simply packaging the code with setup tools for a Vertex AI pre-built container.